Hi, this is Divya, Assistant Professor Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about types of configurations in robots. What are the types of configurations we have in the robots? Okay, we'll see in this diagram. We have different types of configurations: Cartesian configuration, cylindrical configuration, spherical configuration, and articulate configuration. What is Cartesian configuration? We have four types: Cartesian, cylindrical, spherical, and articulate. What is Cartesian? The Cartesian configuration is that where it performs, where we'll have three joints. All the four configurations will have three joints. Okay, Cartesian, cylindrical, spherical, and articulate. They have these four have three joints, where each one will perform their own specific task which is assigned to them. Right? Cartesian, which is simple, like as a pick and place robot. So as Cartesian is belong to that kind of robot, and cylindrical is that where the object rotates in cylindrical motion, where the object, in the sense where the robot rotates in cylindrical motion. Cylindrical motion, it is whether it is used to pick and place or else it is used to welding or painting or any kind of operations or tasks which this can perform. What is spherical? The spherical configuration is that where the robot end effector rotates in a spherical form. Okay, in spherical structure, the robot works. Right? What is articulate? Articulate is similar to that of these three robots, where it can perform in a circular motion or in a spherical motion. Okay, it have three connectors or three joints, where it can also be used for pick and place. It is also used for welding purpose and painting cars, etc. These kind of works can be done by these kind of robots. Next is workspace analysis. Importance of workspace analysis. Critical for evaluating a robot's capabilities and limitations. Okay, critical for evaluating a robot's capabilities and limitations. Guides the design and implementation of effective robot tasks within a specific defined space. Okay, guides the design and implementation of effective robots tasks within a defined space. The workspace is a limited space, right? In that space, how the design and implementation of the robots takes place. That defines the workspace analysis. Factors influencing workspace. What are the factors will be influencing workspace? Joint limitations. Consideration of joint ranges and constraints. Right? Next is physical constraints, including obstacles, boundaries, or workspace limitations. Factors influencing, what are the factors influencing workspace is that joint limitations and physical constraints. Visualization of workspace. What is visualization of workspace? Graphical representation of robots' workspace demonstrating reachable points and areas. Okay, highlighting how joint limitations and physical constraints impact the overall workspace. The joint limitations, we have a certain limits of joints to be to design a specific robot. Since we have only three joints to be used in this kind of robots, so the joint limitations and the physical constraints impacts the overall workspace. If we are going to have a four joints robots, here the overall workspace will be impacted, right? Affected. So likewise, if we are going to have a specific workspace to perform a specific tasks by the robots which is going to be designed for that. Okay, Dynamic workspace. What is dynamic workspace? Understanding how workspace changes dynamically as the robot moves and interacts. Okay, the workspace changes dynamically as the robot moves and interacts with the outside environment, right? Empathizing the adaptability of the robot to different operating scenarios. Since we can, the example for this is the humanoid robots. Wherever it can move, okay, it will adapt to an outside environment, whatever it may be, right? That is the dynamic workspace belongs to. Next, reachability. What is reachability? Workspace reachability and configuration reachability. In robots, reachability refers to the ability of the robots and effectors to reach a particular point or area within its workspace. It depends on the robot's kinematic structures. Okay, the workspace reachability depends on the robot's kinematic structures, joint limits, and potential obstacles. Configuration reachability. It can reference to the ability to achieve a specific robot configuration, that is arrangement of its joints. Okay, this can refers to the ability to achieve a specific robot configuration arrangements of joints from its starting position, right? This involves calculating the joint angles necessary to reach the desired configuration and checking if those angles are within the robot's physical limitations. These are the reachability. Okay, the angles will be checked and the joints from the starting positions will be checked, and depending on the kinematic structures and joint limits and the obstacles whether in the robot way, these can be identified by the reachability. Next, applications. What are the applications we have? As I told you already, the configurations, right? These are the articulate robots, Cartesian robots, SCARA robots, delta robot, polar robots, cylindrical robots. These are the types or the applications of these are the configuration and concepts. Depending on that, these applications has been developed. Thank you.